How should customers, like our customers, be thinking about the role of coherent optics versus other technologies inside the data center? And maybe you could comment about what bets we have made in our R&D, some of our more recently announced products like Vesta and Nitro, and how do they fit into this bigger picture?
Yeah, that's a good point, Rebecca. And in the frenzy, there's so many announcements and so many demos and booths and stuff. It's easy to get lost in the myriad. I step back sort of and think about it as a continuum. I think I've said this before. It really is a continuum as to what technologies fit for which part of the application. When you think of, say, within a shelf or up a rack all the way to across the Pacific Ocean, right? So those are the application spaces. Now, as the capacity goes up, you still have to look at it as a continuum, but there is a bit of a shifting, if you will, of technologies. So if I start, deep in the data center, of course, there's copper and, basic IMDD signaling over copper. And, frankly, you stay there as long as you can because it's lower power and lower cost. And this is coming from the optics guy, of course, right? Because that's the right solution for transmission in there. And I'll tie it into your question, Rebecca. That's where Nitro fits in. One of our technologies that is emerging from the Nubis acquisition is this redriver that helps extend the reach of a copper interconnect, of a cable interconnect, while keeping the power as low as possible. So that's the first step. At some point, though, the physics gets you, and then you need to move to optical. And then you use optical, but with simpler coding like IMDD. And that's where you see things like co-packaged, near-packaged optics, even some of the basic faceplate optics. And that's where our Vesta product line, also from Nubis, comes in. Co-packaged optics, offering interconnect, componentry that allows 6.4 terabits per second to be connected from close to a GPU or a CPU up and down racks and across the data centers themselves to, nominally a couple of kilometers. At some point, that breaks, of course, and then enters coherent assisted, or as we call coherent-lite. And that's where investments and technologies we've been developing for the last couple of seasons will start to play a role as you get to longer reaches in the campus, as well as outside some of the campuses, but in close proximity. And then ultimately, of course, you take the next step to go over distance in the metro, regional, long haul, and subsea. And then you put on full bore coherent, if you will, with varying modulation schemes and signal processing enhancements that allows you to always get the highest capacity for the lowest cost, power, and space that you can.
One of the things that surprised me at OFC was the debate of whether it was going to be copper or optical or IMD or coherent. It's an and. The question is at what rate and what distance. And as you increase distance or as you increase rate, copper will go to optical and IMDD will go to coherent. But it's an and.